Question number 19, we got the sun, the moon, and the earth. We're going to approximate them as circular orbits. And it says state unit, I can kind of jot my thoughts up, but I think we kind of know where this one is going, right? That I would jot down all the universal gravitation stuff. So Fg is G mm over r squared. G is gm over r squared. V is 2 pi r over t, and centripetal is v squared over r. That's what we start with, and then we're just going to use it from there. So state Newton's law of universal gravitation, that's Fg is G, big M, little m over r squared. I don't even know if there's a lot that we could add to that. That's simply all I would want to say. And just to kind of be sort of clear on this, boy, they're really clear on this. That's all they want. And yeah. Okay, one small IB thing. When they say state a law and you want to write the formula, you have to say what each letter means. So G is a constant. That's 6.67 times 10 to the negative 11th newtons, meters squared, kilograms to the negative 2. M is mass of planet. Little m is mass of satellite. And I'll say planet or star. M is mass of satellite. R is distance from center of each. Okay, so that's how I would state that. And then F is the force. That's how I would say that. All right, now on the diagram, add 2 arrows to show the directions on which the forces act on the moon. So here, the sun is going to pull the moon towards the center. So, whoops. That's going to be, so we have the sun, and I'm going to draw the sun arrow in tangerine. So this is Fg of the sun, and then we're going to actually have here Fg of Earth. Right. The arrows aren't necessary to scale, it's just this is how I can draw them given the distances. So let's go ahead and look at the next part. Calculate the Earth force versus the sun force on the moon. So Fg of Earth is going to be G, m of the moon, over r to the moon squared. And let's compare that to the sun force. Fg of the sun is G, mass of the sun. And you know what? Let me add a little thing here, mass of the Earth. And then this will be mass of the moon. Over radius, and I need to add one more thing here. I'm going to say Earth-Moon radius versus Sun-Moon radius squared. And let's get these two ratios written out now. So, and we're going to do a little bit of rules, fractions here. So we've got, and you know what? I don't like the way I've written these. Let me just write them a little bit neater so you can actually read them. So to be very clear, you don't need to erase anything. I'm just going to write it neater so you can read it. So here, the force of gravity on the moon from the Earth is going to be G, mass of the Earth, mass of the moon, over the radius from the Earth to the moon squared. The sun gravity equation is going to be G, mass of the sun, mass of the moon, over the radius from the sun to the moon squared. And now what we're going to do is we're going to take Fg over Fs. Fg of Earth over Fg of the sun. Now, a rule from algebra: to divide two fractions, you multiply by the reciprocal. So G me mass of the moon over REM squared times RSM squared over G, mass of the sun, mass of the moon. We get some cancellation. And so we're going to end up getting ME RSM squared over MS REM squared. And when we actually put in those numbers, we'll end up getting, I'm getting a ratio here of about 0.46. Okay, no units. Now, if the Earth was not present, what would be the motion of the moon? The moon would orbit the sun with a period of 1 year. Because orbital speed would be the same as Earth, since the distance is about the same. All right. And then for part 2, a white billiard ball. Oh, actually, that's problem 19, right? Was this problem 18 that we just did? It is. So problem 19 will be the next problem. We'll take a look at that in the next video.